How's it going, Accelerated Chemistry students? This is Mr. Spurk, and this is your Chapter 16, Section 2 notes, all over concentrations of solutions. So we're going to start by talking about molarity. The concentration of a solution is a measure of the amount of solute that is dissolved in a given quantity of solvent. A solution that contains a relatively small amount of solute is a dilute solution. A concentrated solution contains a large amount of solute. Molarity, or capital M, is the number of moles of solute dissolved in 1 liter of solution. Molarity is also known as molar concentration. To calculate the molarity of a solution, divide the number of moles of solute by the volume of the solution in liters. So you see that it's molarity, which is capital M, equals moles of solute over liters of solution. So intravenous solutions are often administered, so that's just an IV. They're often administered to patients in the hospital. When the saline solution contains 0.90 grams of NaCl and exactly 100 milliliters of solution, what is the molarity of the solution? So if you notice, they gave us NaCl in grams, but we need it in moles. So our first job is to convert grams of NaCl to moles of NaCl. And we know how to go from grams to moles. We're going to use the molar mass, and that is 58.44 grams of NaCl for every 1 mole of NaCl. And that leaves us with 0.015 moles of NaCl. Now, if you notice, it's moles of solute per liter of solution, and we have 100 milliliters of solution, so we need to convert that to liters. So that's going to be 0.100 liters. And when we divide that through, we get 0.15 molar NaCl. So that's how concentrated this solution, this IV, is. Both of these solutions contain the same amount of solute. But you can tell by the color of solution A on the left that it is more concentrated than solution B on the right. Solution A has the greater molarity. The more dilute solution B was made from solution A by adding more solvent. Because remember, it's moles of solute per liter of solvent. So if you increase the volume, which is the bottom of that fraction, the molarity is going to decrease. So they show you little particles being more spaced out on the solution B. It's because they're more dilute. So we can also make dilutions. So diluting a solution reduces the number of moles of solute per unit volume, but the total number of moles of solute in the solution doesn't actually change. The moles of solute before the dilution equal the moles of solute after dilution, because all we're doing is adding more solvent. The definition of molarity can be rearranged to solve for the moles of solute. Molarity equals moles of solute over liters of solution, but we're going to rearrange that to be moles of solute equal to molarity times liter of solution. The total number of moles of solute remains unchanged upon dilution. So we can set up this equation to help us solve when we need to make dilutions. So that's M1V1 equals M2V2. And that is molarity of the first solution times the volume of the first solution is equivalent to the molarity of the second solution times the volume of the second solution. So how many milliliters of aqueous 2 molar MgSO4 solution must be diluted with water to prepare 100 milliliters of aqueous 0.4 molar MgSO4? So we are given a molarity M1, and we're trying to figure out what is the milliliters, so that would be V1, and then we're given M2 and V2. And it doesn't really matter which one is M1 and M2, or which solution we call 1 and solution we call 2, as long as we're consistent. These are the two pieces of information for one solution, and these are two pieces of information given for the other solution. As long as we keep those straight, we can solve for these problems, and it doesn't matter which one is solution 1 or solution 2. So we set this up. We set up M1 V1 equals M2 V2, and we're solving for V1. So we're going to rearrange this. V1 equals M2 V2 over M1. And when we plug these values in, we have 0.400 liters, or molar, I'm sorry, times 0.100 liters divided by the molarity of the first solution, which is 2.00 molar. So V1, when we multiply and divide that through, is 0.02 liters, or since it asks for us in milliliters, we're going to convert it to milliliters, so 20.0 milliliters. So basically what we did was we had a 2 molar solution, which is more concentrated, and we wanted to figure out how we can dilute the solution to obtain a 100 milliliter solution of 0.4 molar. So what we solved for was how many milliliters of solvent we needed to add to dilute our solution. So we can also look at solutions as percents. So percent by volume of a solution is the ratio of the volume of solute to the volume of solution. Isopropyl alcohol is sold as a 91% solution by volume, typically, which we've used that in the lab a few times now. You could prepare such a solution by diluting 91 milliliters of pure isopropyl alcohol with enough water to make 100 milliliters of solution. So it's percent by volume equals volume of solute divided by volume of solution times 100%. So what is the percent by volume of ethanol in the final solution when 85 milliliters of ethanol is diluted to a volume of 250 milliliters with water? So like we just saw on the previous page, we are just going to take the volume of the solute divided by volume of solution. So we have 85 milliliters divided by 250 milliliters times 100%. That leaves us with a 34% solution of ethanol. Another way to express the concentration of a solution is as a percent by mass, or percent, and then we put the parentheses mass over mass. So the percent by mass of solution is the ratio of the mass of the solute to the mass of the solution, much like the volume one we just solved for. Percent by mass is sometimes a convenient measure of concentration when the solute is a solid. Just makes it easier so we don't have to convert it to moles and then get molarity, but that's typically only when we're working with solids. So how many grams of glucose are needed to make 2,000 grams of a 2.8% glucose by mass solution? So if you notice, we were given different pieces of information here, and we know that our equation is the percent by mass equals the mass of the solute divided by the mass of the solution. So we're going to rearrange this equation because we want to get the mass of the solute, because it says how many grams of glucose, is equal to the percent by mass times the mass of the solution. So we can plug these values in. So the mass of solute, or the mass of glucose, is going to be equal to 0.028, because remember, we can't multiply by percents. We need to divide it by 100 to get it back to its decimal value, and multiply by 2,000 grams, because that's how large of a solution we're making. Multiply that through, and we get 56 grams of solute, or glucose. Alright, so in review, to calculate the molarity of a solution, divide the moles of solute by the volume of the solution in liters. Diluting a solution reduces the number of moles of solute per unit volume, but the total number of moles of solute in the solution does not change. The percent by volume is the ratio of the volume of solute to the volume of solution. Percent by mass is the ratio of the mass of the solute to the mass of the solution. As always, all the information on these slides has been acquired and adapted from Pearson Chemistry 2012 edition of the textbook, Resources CD, and PearsonChem.com. Have a great rest of your day.